I'll just give it another minute before we start off. People are joining. Okay, hello everybody, welcome to this webinar, wherever you are. My name is Richard Hellebrand. In my career, I've worked for more than 30 years in the coal, agrochemicals and polymers sectors of the process industries. And most of that time was in engineering management of COMA, Seveso, upper tier plants. So I'm really delighted to chair this webinar, which is about developing reliability culture. And it's going to use a case study at a refinery. A little plug at the end of the webinar, I'll advertise a related in-person event that we're running on the 18th of March in Wilton in the UK. So if you're in the UK, don't leave early at the end of the webinar. Okay, so I'll now show some introductory slides before handing over to our speakers. For the housekeeping, the event is being recorded. It will be available on YouTube. We've disabled your mics and your cameras for a smoother presentation. If you attend more than about 60% of this webinar, you'll automatically get a CPD certificate, whether you like it or not. Any questions, just pop them in the Q&A or chat available on Teams, and we'll answer as many of them as possible within the time of the webinar. I'll keep track of those in the background. We also we've got a main presentation, then some chat. Slides will be available. Again, they'll be emailed out as a PDF to people who've attended more than 60% of the webinar. And then finally, to ensure privacy and data security, if I spot any AI chatbots, I will make them leave the meeting. Not permitted to take notes that way. Pay attention, it's easier. If you don't know who we are, the Institution of Mechanical Engineers Process Industry Division, we represent a lot of the big sectors in the process industries in the UK, and a central point for mechanical engineers to connect, share expertise and promote best practices. We organise lots of events, conferences, etc., etc. There's a QR code. When you want to get the slides, you can use that. You'll go to us. A little bit about equity, diversity, inclusion. Engineering is for everyone. We don't care what your background is. If you're an engineer, we're fully inclusive. You know, colour, nationality, sexual orientation, doesn't matter. We're all engineers, we're all here. We can all learn from each other. If you want to get involved, contact us afterwards. And then just before handing over to Connell, perhaps the other two people could pop their cameras on. Yeah, and I'll just stop sharing for a second because then it'll be going on to Connell's slides anyway. So you can see Connell's there. Connell, introduce yourself, please.
Hi everyone, I'm Connell, a senior consultant with TUV. I work in the Warrington office and I lead a small team of integrity consultants out of that office as part of the wider integrity management UK team. I've been working for TUV for over 10 years, mainly in oil, gas and petrochemicals industries.
Okay, thank you. And you'll do the main talk in a minute. And just because we've got Ryan there as well, Ryan, introduce yourself.
Hi everyone, so I'm Ryan McEwen. So I work for DSM Firmenich at our Dalry site, which is an upper tier COMA site. So I'm the lead for our operational support department, which looks after the maintenance, reliability, asset integrity, as well as the operations of our utility systems, which feeds our vitamin B and vitamin C plants. I've had various roles on site for the last 10 years, from operations manager, SHE manager, as well as asset integrity and process safety. So I've got good level of experience across the chemical plant, and happy to answer your questions.
Fantastic. So Connell, over to you if you want to pop your slides on the screen and make a start.
Thank you. Are they showing okay?
Yeah, perfect.
Okay, great. So the theme of this presentation is improving safety, increasing production, and reducing OPEX through improved reliability. And it's focused on a case study of an asset integrity management implementation that we did over a period of years with a downstream operator in Europe. So first of all, the agenda. I'll give an introduction into our vision of what reliability culture and asset integrity management is around, and then what an example aim vision would be, what we think we can achieve through it, and then I'm going to look at this case study of how we transformed asset integrity management across multiple sites and the steps within that. And then we're going to look at non-intrusive inspection and the potential and benefits that can have for improving both reliability, safety, and improving output and reducing costs in the total expenditure. And then last, we're thinking about how you scale, how you actually make these projects happen. So straight into the detail. First of all, why would we want to achieve a high reliability? Well, first of all, it helps to maximize asset availability and output. So we maximize profit or our top line sales. But we also will minimize equipment repair and replacements, and that'll minimize the associated costs with that. So that'll improve our bottom lines. But we also want to ensure asset integrity. That's to ensure safety. So we have a key role in supporting process safety management activities, but also personal safety. So things like machinery guarding would come under asset integrity, as well as the larger sort of pressure systems integrity and inspection activities. And also we want to ensure that we don't lose containment and have adverse effects on the environment through contamination of air, water, or the ground. And finally, we want to ensure product quality. So in certain process industry sectors, reliability can have a huge impact on quality, and that could be a result of lost product or reworked product. We did do a study a while back for a company that had a capping machine to put the lids on vials of medical products, and it was a very unreliable machine. And every time it failed, it was an 8-hour complete clean, shut down, repair, and restart. So it took them a whole shift to actually get the machine clean and sterilized enough according to their good manufacturing practices that they were able to start up again. So every failure of that machine had a massive impact on lost. They'd lose batches. They couldn't be confident in the product. So the quality issue in certain sectors is big as well around reliability. So what do we mean by a reliability culture? So reliability culture is one where everybody at all levels is continuously involved in the identification, understanding, and application of appropriate reliability behaviours and practices throughout an asset's life cycle. And you could probably copy and paste the word safety and put it in there. It's very similar. We don't go around saying that, well, safety is the safety department's responsibility, so I can ignore things. And similarly around reliability, we don't want people to say, well, that's the maintenance department, so that's the reliability department's problem. We want people from engineering, purchase and projects, all of the different disciplines to take ownership of how they can affect reliability of the asset over its life cycle. And you see the results of a good or a poor reliability culture across various areas. So this little diagram on the right hand side is the sort of model that we might use when we're doing a reliability assessment. So looking at different areas, you can see the effect of reliability come through. So of the culture come through in terms of how well practice is applied in reliability operations and maintenance, people's competence and how competences are managed and how behaviours are managed. But you also then start to see it through some of the results. So you'll actually see potentially better condition of assets, better reliability performance, and better quality of information. So you do see the effect of a good culture come through in multiple areas. But of course, the culture needs a combination of the right people. So you need the right behaviors. Without the people, you're not going to get a culture. But you also need to make sure that you've got processes at work. Because there's nothing more damaging to culture than ineffective processes that create boundaries, that create siloed organizations, blame culture. So you need to have effective cross-departmental processes and workflows to ensure that culture can be built. And also you need technologies. So you need to be able to use the tools, the right tools for the job, so that you are giving people the foundation to succeed. So you do need to support this culture with effective processes and investment into technology. So if you do achieve a high reliability organization and you achieve a strong reliability culture, you can hopefully achieve signs of a high degree of involvement, consistent application of required behaviors. So it's not just in certain pockets you get good practice and good behaviors. You see that widely across the business, and there's a relentlessness within the business of how to improve. So people aren't satisfied that we've achieved green on our KPIs. They say, well, let's revisit the KPIs and push for the next level of improvement. And you can sort of see what you could say for the different levels of operational reliability excellence on this chart on the right, that you get the reactive firefighting mode, and the hardest step is to get out of that firefighting mode into the proactive mode, where you're looking ahead and managing risks proactively. And then the next level up is to get this reliability culture, this continuous improvement of reliability. And then for some companies, depending on your market, your industry, it might be worthwhile striving for a world-class reliability performances, but in many cases, this you're better focusing your efforts elsewhere. So we don't always need to be world-class in reliability. We can potentially just be good enough, just have this reliability culture to achieve the level of reliability performance we need. If we do that, we'll get effective teams. If we get involved leadership, then we can start having consistently applied processes, well documented processes, and effective knowledge management, and everything starts to work more effectively, and we get a virtuous circle of improvement. So our vision for asset integrity as one element that supports a reliability culture is that through effective people, processes, and technologies, we can try and achieve a 50% reduction in cost as to what might be considered good enough, and an 80% reduction in vessel entries if we do best practices in primarily through non-intrusive inspection. But if we take a real effective look at how we manage our risks and how we manage our integrity issues, we see great potential for improvements in costs and the risks associated with vessel entries. And the value that this brings to the industry is we can try to eliminate failures on aging plants, because we can hopefully get a better handle on our failures and our understanding our damage mechanisms through a high reliability culture and effective tools such as NII to support potentially an even better integrity assessment than you can get through visual inspection, improve safety and integrity, reducing the shutdown duration, because we can either take work out of shutdowns or we can do inspections more effectively. Perhaps we can just cool down a vessel. We don't need to isolate it or open it up. Increasing turnaround intervals by maybe having intermediate inspections or having a better understanding of our asset condition, and improved production uptime. We have fewer unplanned events where we need to take equipment offline, because we've got a more effective picture of our asset integrity. So this is a case study of a project that we ran from 2020 through to 2024 with a Hungarian company called MOL, their downstream business. So they've got 3 refineries, one in Slovakia, one in Hungary, one in Croatia, and a petrochemical site in Hungary as well. And they were trying to put together an integrated asset integrity management program. So the strategic issues facing their industry, there's a long-term decline in petrol and diesel demand across Europe. So there's overcapacity in the industry. They've got tough competition in a difficult market, and they've got aging assets. So their underlying reliability is starting to decline as these assets age. They're getting into that bottom end of the bathtub curve, so they can't just continue with business as usual. And these aging assets were leading to a high level of failures and unplanned outages to deal with integrity issues. And what they did have was 3 independent companies which had been bought by MOL, and they had different procedures, different ways of working. So they had a lack of consistency and standardisation across the group. And local initiatives hadn't really achieved the improvements that they wanted them to. So there were pockets of good practice, but they weren't really getting sustained and then spread out across the group, the wider group. So at the start of the project, we developed some project objectives and a project charter to develop a business case for the project. And the main game was to transition them from a reactive to a predictive or preventative maintenance organisation by basing decisions on condition and risk. And by adopting an asset integrity management program, we would identify critical assets and focus inspection and remediation efforts on the highest level of risk. So the legislative environment was very compliance driven. So all pressure systems were being inspected as per the regulatory requirements, and it had slipped. The culture then had slipped into being a compliance base rather than a risk based integrity culture. So we needed to get back to that risk based approach. And the idea is that we work as one team across the sites. So we develop one set of procedures, one common way of working, and then we develop knowledge transfer, so that as the project progressed, we transfer knowledge and capability to the local teams. And supporting that vision with the tools and techniques to achieve asset integrity assurance, so effective RBI and inspection, advanced NII and NDE techniques, so the implementation of more modern inspection practices, and then the big goal to reduce turnaround durations and costs. And the project was run over 4 phases. So the first phase was to set the framework. So we developed 11 procedures, developed that vision, and then we started a competency development program, and then we started the implementation of a single integrity management software solution, and then how that software would fit in with the SAP system. So once we developed that baseline and agreed the framework, we then started to show. So we led as TUV the integrity reviews. So we were doing writing corrosion control documents, then using those in RBI assessments, then looking at additional considerations around dead legs, how to manage insulation, how to manage corrosion monitoring activities. So we were looking at a whole integrity review for the different for sort of pilot assets on each units, and then we were also rolling out the software, so training the users, showing them how to use the software, developing the templates and the forms. And then once we'd done that to establish the sort of standard of what was expected by writing the framework procedures and then implementing them on pilot units, we moved then into a teach and coach phase. So that was where we started to collaboratively deliver the corrosion control documents and collaboratively take part in the asset integrity reviews, so the RBI reviews, and developing the inspection plans. And alongside the sort of doing work, there were also activities to develop competence. So we had a forum where the people from the different sites could join on Teams meetings and discuss issues, share learning, and we could reinforce when they had any technical questions. We could answer those. So over the course of that year, that led them to become almost independent, and then the final phase of the project was a phase of sort of 12 to 18 months of support. So now MOL were leading and delivering the reviews on their own, and we were providing a support and review, so a technical sort of support process, and then we were carrying out scheduled audits. So by the end of the third phase, by the end of those 4 years, they were carrying out the work independently to a standard that we could audit against. So this was a great example of how we implemented a digital solution, an asset integrity management program, and then also transferred the knowledge of how to sustain and run that process as an independent operator without an external service provider or consultant continuing to provide support. So a great example of that. And then this mentions the some of the savings that were envisaged from the project, and the vision was to increase integrity assurance, so increase the amount of or reduce the amount of unplanned failures by 25%, reduce turnaround durations by 15%, turnaround costs by 10%, increase unit availability by 10%, and then identify opportunities where we could apply non-intrusive inspection, and although the legislation was still very much driven by internal visual inspection, we made a case. We did studies to say we could do a lot of non-intrusive inspection, and then that has now opened the conversation with the regulator, because of course the shorter the turnaround, the more production and the more tax revenue the government gets. So where we're able to demonstrate that we can safely apply non-intrusive techniques, where they're either as good as or better than internal visual inspection techniques, we're able to put a case together that's then moving to the next stage of potentially changing some of the compliance-driven legislation and moving to a more risk-based approach. So then moving on to talk a little bit more about non-intrusive inspection. So the traditional approach, internal visual inspection, intrusive inspection, we traditionally put an inspector inside the vessel to carry out a visual examination. But within the UK and increasingly in other countries, there's no legal requirement to carry out an internal examination of a pressure vessel. All the examination needs to do is be effective at detecting the predicted damage mechanisms, and also providing sufficient information to enable the vessel's integrity to be assessed and considered suitable for operation until a future interval. And the future interval can be defined by the findings of that inspection. So all you need to do is understand how well the equipment is withholding its damage mechanisms, how well it's standing up, and then say, well, what would be a suitable examination after that? There's no actual requirement to do the internal inspection. But if we do an internal inspection, we need to shut down the vessel, and there's a lot of work needed to prepare that vessel for inspection, to make it safe to put a human inside, and then also to return it to service afterwards. And then also, once you've returned it to service, there are risks with leaks at joints when you put those when you reconnect the pipe and repressurize. And when you do the inspection, you have the risks of confined space entry, and there are other safety and environmental risks to do with decontaminating, cleaning vessels, and what you do with that inventory. So like I say, entering pressure vessels increases risk. And between 2003 and 2011, to take an example period, there were 22 fatalities in the UK resulting from confined space entry. So that excludes workers killed by trenches and collapse and trench work. So 9 of those was a result of oxygen depletion, and 13 was due to other accidents. So there are multiple risks associated with confined space entry. There's the asphyxiation risk, but there's also the risk if something does go wrong, it's much harder to have a rescue and an escape plan. And we also have this risk of hydrocarbon leakage when we prepare for a vessel entry. We need to break flange connections and then remake them, and it does create that potential for leakage. So there are several risks associated with vessel entry. And then also when we're removing the inventory from that vessel, we might be flaring to purge the contents out, and then we've got to clean the vessel. So when we've got to dispose of that wastewater and any residual contamination that's in there, and then any fugitive emissions which are associated with the flanges which haven't been resealed adequately. So if we do non-intrusive inspection, so this is inspecting from the outside of the vessel, we avoid that requirement for entry into a confined space to perform the examination. And there is increasingly a sort of halfway house, which is robotic inspection. So we do still need to do some preparation to do a robotic inspection, but potentially not quite as much as for a human entry. But for NII, we're talking about inspecting from the outside totally. In some cases, the inspection could be undertaken with the equipment online. It might depend on the operating temperature, and it might depend on the associated risks with being close to equipment. So it can sometimes, but not always, be undertaken with equipment online. And it is finding increasing adoption across the process industries. So as the NDT techniques get better and the data processing capability gets better, it becomes increasingly viable, and it's becoming increasingly adopted across process industries. And it has delivered significant improvement and financial benefits without compromising process safety. And we've got some examples of that later on in the presentation. But it does require a high level of understanding. So you do need to have a good corrosion risk assessment, risk-based inspection plan. You do need to really understand the deterioration mechanisms, and not every vessel is suitable for non-intrusive inspection. Either there's some sort of geometry which presents inspection of areas which are of concern, or the nature of the degradation means that it's not possible to predict the locations where damage could be occurring, or the severity of the damage could be so high that that the NII is not recommended. And there's a guidance document that can help you make those decisions. So in 2017, we did a study. We led a study with the Oil and Gas Technology Centre, now the Net Zero Technology Centre, to see what the potential is for implementing non-intrusive inspection off the offshore sector in the UK. And we found there was a potential saving of $500 million a year from a combination of increased production costs. So that's the red bar on the chart, and then a reduction in the process and mechanical costs. And you'll see that on the green, the inspection cost, the actual inspection cost does generally go up, but the reduction in downtime and the reduction in the preparation costs is that much lower that it far more than compensates for that loss. So we did a comprehensive survey to see how extensive the use of NII was within the UK continental shelf, and then identify what this value gap was. So if everybody who wasn't using NII techniques were to adopt them, given the typical vessels that you might find in the offshore sector, what benefits could we find to the industry? And then also what the industry readiness was. So what barriers needed to be overcome before people felt ready to adopt NII? And the barriers were process barriers, technology barriers, and then also behavioural and cultural ones. So a mixture of issues were preventing it. And we found that typically 85% of pressure vessel inspections required equipment to be shut down and isolated. And 95 to 97% of the cost of that invasive inspection was the enabling work and the lost production costs. Maybe in onshore process industries, the lost production costs aren't quite so high, but certainly the enabling work still has a significant cost. And generally, we found that for a lot of companies, NII wasn't even considered. They had policies of intrusive inspection was generally mandated, and RBI even is often not used or has not really been effectively applied. So the real risks weren't being understood. And I guess a thought would be what could be the biggest obstacle to change in the onshore sector. We certainly found that just doing what they'd always done was one of the big barriers in the offshore sector. But the sort of cost pressures that they've seen from 2017 onwards have created a lot of change in that industry since this survey came out. And you can see that across operators, there was different degrees of savings because they were in different levels of RBI effectiveness and NII effectiveness, but all operators did find that there were potential to reduce NII inspection costs or total cost of inspection from NII. And then other studies that we've done, these are sort of real studies for real companies. So for an onshore refinery, we looked at 164 vessels, and we found that 58% of those were suitable for NII. A study we did for BP in the Caspian region of their offshore platforms, we looked at 261 vessels and found that 56% were suitable for NII. And then for a third company, we looked at a mixture of onshore and offshore assets, and again found 60% were suitable for NII. So there's that 55 to 65% region is entirely plausible for achieving a reduction in the number of vessels that we have to do internal inspections for. So there's potential for significant benefits from adopting non-intrusive inspection. So we can improve safety and production through non-intrusive inspection, and we can also take advantage of the increasingly advanced NDT techniques. So even where we can't perform non-intrusive inspection, we can do things like replace radiographic testing with TOFT and phased array, so we don't have to do inspection work at night and plan in the radiographic work in the night and then other activities in the day. We can compress shutdown periods by being able to do advanced NDT alongside other maintenance work inside the turnaround. Like I say, where we can use NII, we can use NII, and then also increasingly we have the opportunity to do NII on screen. So there are a number of techniques which can be used either on high temperature equipment or on actually equipment that's still insulated. So we can do screening techniques on equipment that's operating at high temperature while the insulation's still on. And then also we can use condition monitoring. So we can use sort of permanent in-place monitoring as an inspection technique. But then we can also do process optimization. So if we can reduce the rate of fouling of equipment, then we potentially don't need to open it up every turnaround to clean it. If we could control process conditions, we maybe don't damage packing inside vessels quite so quickly. So potentially, even if there's an operational need to go inside vessels, which then drives an internal inspection policy, we can potentially get every other turnaround between the need to go inside by monitoring and optimizing our processes just to look after our equipment a little bit better. So then, in summary, how do you succeed in improving safety, production, and reducing OPEX through improved asset integrity and adoption of techniques through adoption of techniques such as non-intrusive inspection. Well, you need to understand that the project is first and foremost a transformation and culture change project. So it's not merely just a introduction of new processes or introduction of new technologies. You're really changing how people think and how people behave. So if you see this change management model on the right hand side, you need to create the conditions for change. So you need to have that sense of urgency, why we should change, and then you need to build a coalition. So get enough people from the leadership level, the sort of the engineer level and the technician level who are willing to make that change happen. You need a clear vision and strategy so that you've got a guiding star you can all sort of line up behind. And then beyond that core team, you need to generate supporters and buy-in across the wider business through communication. And then when you do introduce new practices, provide help and reduce barriers. So do what you can to make things easy, take away the pain, generate short-term wins. So think about how to sequence things so you can get a real short-term benefit. So if there's any particular upcoming turnarounds, can we do work for that specific turnaround, get those quick wins? And then you need to maintain the momentum. So you need to build that capability internally within the business so that it does change. And then that will require continual pushing from the leadership level, from the sort of engineering level, and also within the inspection and maintenance technician level. So everybody's got to push the change. So having a strong driver always helps. So it could be existential, it could be something around company survival, but it could just be being proactive and responding to changes in the marketplace. Align with your existing culture, history and regulation. It's different within every company. Take advantage of it. Do things that fit with how people already think, and use that. Don't use that as an excuse. Use it as an asset to drive things in a particular way. Get senior management involved and engaged, and have that vision and energy come from them. They need to pull this from the top. But then also build that commitment and support for change throughout the organisation. Get it there at multiple levels. Challenge the regulatory compliance. So it is possible to get away from just the regulator says we need to do it, so we'll do it. You can say, well, we will do it, and how about changing the way we do it in the future? So you, with data and evidence and a good understanding of your assets that you can prove to the regulator, it is possible to start the conversation to make a change. And then also be transparent. Much better to have indicators which tell a mixed picture than indicators that say everything is green. Be transparent and admit that things need to continually improve. And then also make it stick. It's not easy. Asset integrity. You can't give up. Everything on that asset register needs to be considered. But you do a risk-based approach. So you look at what's the most critical equipment, focus the effort there. But you do need to keep that effort going throughout. So then finally, make sure you have experience within the delivery team. And this is a great photograph. This is the sort of formal kickoff meeting from that project with Mole. And you see the number of people around this huge table in one of their boardrooms of the number of people we got on board for this project to make sure we had the right people in the room to both from a senior level guide the project, and from an engineering level to actually deliver the project. And this is a group of us several years later on another project meeting. So maintain that team and keep things going. Thank you. Should I hand back now?
You can just leave that screen up if that's okay. It's fine for now. Brilliant. Thank you, Connell. And that gels with so many things that I've come across in my career. I don't know what Ryan's view is on that. I just add a couple of comments before we start chatting. You said this, but maybe not strongly enough. Don't pick techniques that avoid entries just because they're easy. Competent inspectors and engineers to interpret are important, because otherwise we could end up with unsafe situations. But nevertheless, I do think that there are more and more techniques today than there ever were before. We've got remote operated vehicles, robot techniques. We've got new non-destructive examination techniques, and some of them are relatively cheap. Even the drones are cheap now, that we can use these techniques instead of, and to supplement, and they can reduce costs in scaffolding and all these other things. We haven't really got any questions in the Q&A, but maybe I could ask a question of both of you. Maybe start off with Ryan first, put you on the spot. So have you seen, Ryan, over your career, sort of the effect on turnarounds and shutdowns of the new technologies and this sort of asset integrity management approach?
I think for us at DSM Dalry, probably not. I think we were a little bit more sceptical on the non-invasive inspection so far. I think what we've tried in the past is going like remote visual inspection as a kind of an interim screening tool, and then trying to obviously do every other turnaround as a man entry type thing. But I would probably say one of the barriers, and we talked about it in the presentation, was about the conditions for change. And I still feel that the kind of regulator is obviously getting over that hurdle and convincing the regulator and having the confidence to do that non-invasive inspection and defining that technique is one of the barriers that we still feel is still kind of getting in the way of us implementing more non-invasive techniques.
Okay. Yeah, and that's a discussion that I have with, I know a few people in IMechE, not in IMechE, in Health and Safety Executive, because there's a sort of calibration, if you like, of knowledge about what's possible and not possible that we all have to go through, and also with the inspecting agencies before they will let you move that. But as Conal said, if you make a good argument, you can have an argument or a good discussion with the authorities. It just can be expensive up front. Conal, have you seen? You've seen a lot of things in your career so far, but I'm particularly interested in this. Can we extend intervals between shutdowns and turnarounds? Have you any examples of sort of how what's possible?
Yeah,
not without company names. Don't care about that, but size particularly.
In that NII study, it was quite interesting because a lot of the offshore companies had come from a major, and the major had a very sort of, we will inspect everything on a rigid shutdown interval, and we'll apply that globally because it was the easiest way to manage different regions, different geographies. They didn't have the same level of competence across, so they had a sort of a minimum turnaround and then inspection policy. But then, of course, a lot of these offshore operators, and the same happened onshore, the big groups are breaking up into smaller, much smaller entities. But a lot of them have inherited this turnaround cycle from the parent company that was a minimum standard, not necessarily tailored to their equipment. So if they then, and we did the pilot studies as part of the NII program, we do some of these pilot studies on a few vessels, and you say, well, actually, there's not too much going on inside this vessel. You don't need to do the inspection every 2 years. You could put this out to 4 years, even longer potentially. So we did find in that study a lot of those reduced costs were not just from doing the inspections. It was doing the inspections differently. It was doing the inspections less often. We could push out those intervals. So I think if you've got the competence within your team or within your inspection provider where you are, it's often worth looking at, well, why did we come to the turnaround intervals we got? Can we look at extending those, because often they're inherited from a parent group that you're no longer a part of.
They're certainly often fixed because you have certain things that need inspected: boilers, cooling towers, utility stuff. And I'll give you an example of a plant I was at. When I arrived there, there was a turnaround every 2 weeks, once per year. And when I left, it was 1 week every 4 years. And I was moving it towards 5 years because, and there's a whole things like cooling towers. You can do online inspections, pack scan in the packing. You can put ROVs in the water and check for silt. You can use endoscopes. You don't have to even turn them off anymore. So
Yep.
and the same. If you've got more than one boiler, you should be scheduling them around anyway. But and it goes on with other things. It's always, why do I need to shut down? Why do I need to shut down? And often the cleaning is the thing. And you've mentioned that, I think, as well. Is there a way we can improve the design of this so we don't have to clean? Is there a way we can change the materials of construction so it doesn't corrode as quickly? And things like RBI, risk-based inspection, if you go into all of the failure mechanisms and do it almost like an FMEA, you start to think, well, what can we do to design out the need to go into that thing once a year or once every 2 years or every 4 weeks, whatever it happens to be. So, I'm a big fan of what you were saying.
And often there's a challenge, if you actually challenge from the integrity side, you decide, well, there's no reason for us to go in. And then you challenge on the process side, and we thought, well, I thought you were going to inspect it, so we went in and did the cleaning process or check the packing or something like that. But they don't, the consequence of not doing that is not high enough. Once you take it off the integrity driving the vessel being in the turnaround, then they might say, well, actually, we can take it out as well. So there's often need to challenge from both the operation side, the process side, and the integrity side to see, well, what's the real driver for that internal open up the equipment, and can we avoid it? Do we need to do it as at all, or can we do it less often?
There's a comment, Alan Brogier, that a lot of people know. In many cases, especially offshore, like in Aberdeen, asset integrity is outsourced to inspection providers, where there's no incentive to extend intervals. It's crucial that operators maintain competency in asset integrity. So he's banging on the same drum that I am really about this. We need to drive it. Don't just assume that TUV or whoever else you're using is the competent person. They can make all the decisions. Make sure you've got some competent engineers in your own organisation that drive them, because they work for you. So we need to challenge these things. There's a question. Sorry.
I was just going to say, Richard, it's a very good point. So you do need that competence within your teams. And I think also increasingly it's the awareness of the advancement in NDT techniques and what's going to be suitable for non-invasive inspection. So I do feel at our side that's where we have a little bit of a gap. It's on the awareness side. And I mean, Connell, you spoke about the non-invasive selection technique, and there's a standard and a guidance to drive you through that. So are people fully aware that exists, and you can use that to actually drive some of your decision making?
I'll come. I mean, I mentioned at the beginning. In a couple of minutes' time, I'll move on to some slides and show you an event that's coming up that's going to talk all about this. But there's still the odd question coming in. So this one here from Javier Fitzpatrick. Do you use IMechE study? For people not familiar with it, that's failure modes, effects, and criticality analysis in the study. I imagine that could help in phasing the journey towards a functional asset integrity management system culture.
Yeah, that's a great question. I mean, the way we do RBI within TUV is it's effectively an FMEA study, but really the focus is rather than the focus being on the failure mode, it's more on the failure cause. So it's very similar. You're breaking the vessel down into its components or its different locations, and then seeing, well, what's driving failure. Is it a different type of corrosion? Is it some sort of fatigue? Is it creep? And then if you do have a failure, then you look at the failure mode to see, well, what's the consequence? Is it going to be a pinhole leak? Is it going to be a rapid loss? Is it going to be a catastrophic failure with a large containment? So based on that, the failure mode, you're then driving towards what's your consequence. So IMechE and RBI are very similar processes. The way I see them, it's just the emphasis is on on the failure mechanism rather than the failure
Ryan,
mode.
do you use FMEA at Dalry?
We use FMEA, yeah, but similar to Connell as well. So for mainly our coma assets, it's purely the RBI process, which given you kind of similar findings. You're looking at your damage mechanisms, your consequence of failure, which is driving those types of decisions. So it's similar.
I'm again chipping in for me. It's not just about vessels and piping here. It's about rotating equipment, and certainly in the lower hazard industries, maybe the pressure vessels aren't quite as important. I don't know, or maybe they haven't got the corrosion mechanisms. But if a pump or a compressor falls over, you're down. Whatever happens. So I certainly when Desir Atex came out 20-ish years ago, I used FMEA a lot on all of the existing equipment, from rotating equipment to vessels, hoppers, silos, bag filters, conveying systems, whatever, because it's just a good approach. It just is. You score what can go wrong. You get a cross-sectional diagram of whatever asset you're looking at. You look at all the things that can go wrong, whether that be corrosion or high temperature or whatever it is. And well, what have we got to do to fix this and prevent it? And that's how people design products when they put them on the market, is they use FMEA to design the components. So I think it's a great use in high hazard and low hazard industries. It's exactly the same. It's just another tool in the toolkit that Connell's been talking about, I think.
And the only thing I'd add to that is that if you're going to do FMEA or FMECA, you need to do it properly, and it takes a long time. So target your use of it. Because if you've got an asset list of 10,000 assets, you'll get lost if you just start at the first one trying to do FMEA. So do almost do the criticality bit up front, and then identify where you're going to get the most value from doing an FMEA study, and then you can prioritize the work on that. But it's an excellent tool, but it takes a lot of time.
It does. But it also, to be able to do it right, you realise that you have to train yourself in some of the things before you can even do it, so, which is good. A couple of comments, questions, from Kenny Pollock, also one of Ryan's colleagues. RBI involves quite some resource which comes at a cost. For business, we're under massive OPEX cost pressure, and it makes the justification to spend OPEX on further developing and embracing NII, as it will lead to additional OPEX spend to implement. What's your advice on making a business case for the change, Connell?
You've got to get to that leadership level who can look past the different budgets and see the overall budget, so they can see that the overall asset life cycle cost will be reduced even with that investment at the front end to doing the NII reviews. And also you've got to sell the risk management aspect, because every time you do one of these assessments, not only are you getting a non-intrusive inspection plan, you're getting a better understanding of your asset integrity and the risk to your asset integrity. And also it might be that you find you don't just end up doing NII. You might change your inspection scheme to do a mixture of thorough inspections in the turnaround, but also intermediate inspections, which are much cheaper and easier to do outside of the turnaround. So you might be able to split work. So I think it's a case of finding the right people high enough in the organisation where you can show them beyond the initial spend, the benefits that you get out the back end.
Fantastic. I'm going to just do one more question, and then we'll move on to the closing slides. This is, I hope I can pronounce your name right, Asukwo Cobham. For rotating equipment, we do online condition monitoring, predictive maintenance, and parts upgrades. But for NI, is there anything out there for real-time monitoring of degradation of trays in columns and vessels, which could support extensions?
So you can put strain gauges in place. Now I don't know if they've been applied to this application, but you can put strain gauges in, and strain gauges now that could be under very arduous duty, so high temperatures, or very corrosive environments. And I presume they could be sensitive enough if you installed them correctly on a tray to monitor any deflection on that tray. So you can use strain gauges. There are probably other techniques. There's probably somebody in the audience who's aware of another technique.
And I'm pretty sure that my company, Westlake, has done this or done something very similar to this. So I'll stick my email in the chat if someone wants to talk to me about it offline. We can follow that up. If I haven't got anything, I haven't got anything, but I've got plenty of examples of what is good. Right, I'm just conscious of the time. It's 5 to 1 in UK time. So if I can just move across to start to round this up, and thanks again very much to both Connell and Ryan for your contributions. Fascinating discussions. But we're not quite finished now. Process Industry Division, we're all volunteers. We do quite a lot of webinars. You can see the current program. These are the ones that are on YouTube, but if you can find them if you just scan the QR code. You'll get the slides shortly after this, within a couple of days anyway, and you can get the QR code from there. Highlighting a couple of those events. Introduction to P&IDs. Surprisingly, we're coming across a lot of people who go to HAZOPs or they assume engineers just know how to draw them and interpret them, and they don't. And the same with operations people. It's not something you just inherently learn. You have to be taught it. So here's a good free introduction to it on the 11th of March if you want to come along. You'll find these on LinkedIn as well if you're looking for them. We've actually got a physical seminar about decarbonising process heat coming up at the end of March. In fact, 1 month from now. So if anybody's in the UK is interested in that topic, again, look it up on YouTube. You'll find not on YouTube, on LinkedIn. You'll find that. But the one I want to stress is this one. So in a few weeks' time at Wilton, we've got a absolutely free 1-day seminar. Anybody who can make it, please register. There's a QR code there. Come along. We can only take 100 people, but we've still got places left. And we're going to talk about all the topics that we've been talking about today, but in much more depth with real world examples of the techniques that are possible. I'm going to talk about extending intervals between turnarounds and optimizing them, which again, something Connell's mentioned, but the other people are there, including the health and safety executive, are really on board with this. So I know some might appear to stand in the way, but they're just very cautious. If we can share competence across the industry of how to do these things, it's to everybody's benefit. It's not commercial particularly, and it's dual sponsored between IMechE and EMUA. For people who don't know EMUA, it's the Engineering Equipment Manufacturers and Users Association. They produce world-class guides, so they're really on board with it. So again, hopefully that's been on the screen long enough that you've snapped the QR code, but look it up on LinkedIn, and please register, come along, come and have a chat with us. And that's it really. This is the final slide. I'll just leave it on the screen. If you want to give us any feedback, please do so. There's a QR code for a form for feedback. If you want to get involved, the same thing. There's no reason you can't do. I've already put my email in the chat. I'm a volunteer, but I'm involved with asset integrity, have been for donkey's years, and will continue to be so even after I've retired, which is in a few weeks' time. And at that point, I think we're virtually on the hour. So again, I'd just love to thank everybody. And ask that the two speakers just stay on the line for a couple of minutes, but everybody else, thanks for attending. I'm going to end the event, stop the recording, but if the other two can just hang around for a few minutes. Thanks again.
Thank you.